I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos and posting excellent questions. There has been request on how to find square root of numbers, especially when we have big numbers or we have decimal numbers. Keeping into consideration of the requirements, I am developing this video where we are going to begin with the very basic concepts, take a few examples, and then answer your questions one by one. So we'll begin with the basic concepts. Now let me ask you one thing. The question right here, can square root of a number be greater than the number itself? Think about it. Right? Let's take up how to find square root of different numbers. We are not going to use calculator, and we are going to find these answers within a minute, right? So all this exercise is without calculator. And we are going to use special division method to find square root. Let us first explore what is a square root and what are we trying to figure out. Let's take some numbers. Let's say I'll write down the numbers here and I'll write square of the numbers. Let's say we have 1. In that case, 1 square is basically 1 times 1, and it can be written as 1. 2. 2 square is 2 times 2, which is equal to 4. Likewise, if I have, let's say 5, then 5 square is 5 times 5, which is 25. 10 square can be written as 10 times 10, which is 100. So what do you notice here? We notice that we are multiplying the same number, right? 10 times 10, 5 times 5, 2 times 2, 1 times 1. And then we get square of a number. Now, how do you get square root? Square root is written like this, right? So if within the square root I have same numbers, for example, if I have n times n, then the square root of the number is n. In this case, to find a square, we are doing n times n. Do you see that difference? And that gives you the relation. So, if I want to find what is square root of 1, I know it is 1. Square root of 4 is 2. Square root of 25 is the number 5 itself. 5 times 5 is 25. And square root of 100 will be 10. Correct? So you got the concept. What you really notice here is that every time for a square or a square root, the numbers involved are same numbers being multiplied by one another. So that is the concept which we are going to use in finding square roots. Now let's begin with the major exercise, and we are going to find the square root of a number which is a very big number, 459,684, right? And that too without a calculator. Let us see how to do this. So let me write down this number here slightly bigger so that it helps us in understanding what exactly is going on. The number is 459,684, and we need to find square root of this number. So I'm going to use a very special or different symbol for division in this case, which will be kind of square root, but treat it as a division. Now, the steps involved in this special division is step number 1. we need to group in pairs. So step number 1 here is group in pairs. Now these group in pairs start from the number which is least significant. So let's think about it like this. 4 and then we have 2 zeros here. Think like this. So we'll make pairs from starting from the number here just before the decimal. So that forms the first pair, then the second pair and the third pair. Well, if we have even number of numbers, it doesn't matter from where you start. But if there are odd numbers, in that case it will matter. So pairing starts from the decimal number. You move left for bigger numbers, and to the 10th and 100th place, move right, again in pairs. Right. So we have to now take care of the number 45, which is the first pair. Think about a number which will go perfectly or is slightly less than 45, square of a number, right? So, for example, 6 into 6 is 36, but 7 into 7 is 49. So I could actually use the number 6. So 6 times 6 is 36. So we could use 36 here. So that is how we could do. And as in division, we will now take away 36 from 45. So what do we get? We get number 9 here, right? Now bring down the other two numbers, which are 9 and 6. Then we have to further do this division. Now in this special division, we'll multiply the quotient, this is called the quotient, by 2. So instead of 6, we'll write the number 12 here, and then we'll try to figure out a number which should be same in these two positions, which we can multiply by, and then continue with our division, right? So the idea here is, when you are selecting the numbers in divisor and quotient, then we use pairs. In divisor and quotient. So in this case, 6, 6 is a pair, right? And the next step involved is, we'll double the quotient and bring it down, right? So double the quotient. The number on the top is called the quotient, right? So this is the divisor, that is the quotient. Okay, so now we have to divide by 12 and some other number here, and that number should be selected so that we have same number on both the sides. For example, in this case, you could take, for example, if I take 7, in that case, 7 times 7 will be 49, I'll get 9 here, and 4. 7 times 2 is 14, 14 plus 4 is 18, 1, 7 and 1, 7 and 1, 8. So we could use that number, right? So I'm writing 7 here and 7 here, right? So same number has to go on both the sides. Slightly tricky process, but by the end of this video, you will clearly understand the whole process. So let's now multiply by 7 the number 127. 7 times 7, 49, 4. 7 times 2, 14 and 4 is 18, 1. 7 and 1, 7 and 1, 8. Now let's again find the difference of these numbers and bring down the number 84. So if I take away 16, you have to borrow, right? So you have to borrow, you get 7 here. Here you get 0, since you borrowed 1, so 8, and then here you get 1. Bring down the number 84. And once again, we'll try our division, but we have to now double 67. 2 times 7 is 14, 4, 1. 6 times 2 is 12, and 1 is 13. So we get 134. Now once again, we'll try to find a number which has to be same in these two places. What could be that number? So definitely that number could be pretty high. If I try 9, 9 times 3 is 27, and when we add 2 to 9, we get 11. So we cannot take 9, but definitely we can use a number which is 8, a bit less than 9, right? So let's try 8. So now let's multiply by number 8. 8 times 8 is 64, so we get 4, 6 carry. 8 times 4 is 32, 32 and 6 is 38, so we have 3 there. 8 times 3 is 24 and 3 is 27, 2 to be added to 8, we get 10. So exactly it goes 0 is the remainder. So we can say that the square root of the number, which is 459684, is equal to exactly 678. Perfect. So I hope you have kind of understood this process. Let me just highlight the answer right there. And let's try to understand the process. So what we did was that we wrote a decimal at the end of the number and 2 zeros. From the decimal point, we made groups of 2's, moving left and right. Once we made the groups of 2's, then we started dividing. You have to take care of the very first group from the left side. In this case, the very first group was 45. 6 times 6 is 36. 7 times 7 is 49. So we had to use 6. So we have to write the same number on both the sides. 6 times 6, we got 36. And when we take away 36 from 45, we got the number 9. Now, we have to bring down the other two numbers, and then quotient has to be doubled. So we doubled 6 to write here as 12. We look for the next number. The same number is to be placed in the divisor and in the quotient. And the multiplication of these two is written below 996, taken away, bring down the next two terms and repeat the process. Perfect. So that is how you do this process and get the square root in no time. That was a very big number, and if you do it yourself, it won't take more than a minute. It is less than a minute. Now let's take another example, a smaller number this time. It is, let me write down the number here. It is square root of the numbers 987.65. So I've taken a smaller number. However, we have odd numbers of numbers in this case. From decimal, if I make a group, I'm left with one number alone, which cannot be grouped. On the right side, 65 can be grouped into one number. Correct? Now, we'll continue with our process of division. We have to take care of 9 first, so we can divide by 3. 3 times 3 is 9. When you take away, you get 0, so you bring down the number 87. So when you divide this time, you have to divide by twice 3, right? So when you do 2 times 3, you get 6. So we get 6 here. Now we have to think about a number which will take this position. So there are only 2 digits. Definitely, we cannot take any other number but 1. So we'll take 1 here. 1 and 1. So we get 61. And now the difference. When you do this difference, you get 7 take away 1, which is 6. And if you take away 6 from 8, you get 2. bring down the other two numbers, which is 65. Since this is after decimal, we'll put a decimal right there in the quotient also, and we'll continue the division process. Twice 31 is 62. So we'll write 62 here. And now we'll look for another number. These two numbers should be same. So we have to take care 6 by 26, which is kind of 4 times. It could go, right? So we can try the number 4 here. 4 there also. 4 times 4 is 16. 6, 1. 4 times 2 is 8. 8 and 1 is 9. And 4 times 6 is 24. That works. And we can break down, rather take away. So we get 9 here. From 15, if I take away, you get 6. From 5, I get 1. Right? So that's what you get. So we get our answer, which is square root of 987.65 is equal to 31.4. Is that clear to you? Right. So I hope you have understood the process now. Correct? When there are odd numbers, we'll be left with a single number as it was left in this particular case. Perfect. Now let's take the last example, which seems to be very simple. However, this is the question which is asked many times. Let me give you a multiple choice on this. What do you think is the answer for this particular question? So I'll give you 4 choices. Is the square root of 0.1 0.1? Is it 0.01? Is it close to 0.9 or 0.3? I interchange their positions. So check out, which one do you think is the right answer? Well, let's also do the long division process, or special division process, to figure out the answer. So we want to find square root of 0.1. Well, let's add some zeros here and then group them. From the decimal, we have groups of 2's. To divide by, the first group is after decimals, so we have to put 0 and decimal. Is that correct? So 10 goes with what? See, not 1, 10. So it goes with the number 3, so we get 3 here, right? So 3 times 3 is 9, and when you take away 9 from 10, you get 1. Bring down these 2 zeros. Perfect. And continue with your special division. Twice 3 is the number 6. And we are now looking for the next number. So if 6 is the case, I cannot take 2, because 6 times 2 is 12, which is more than 10. So I have to take the number 1, which gives me 61. And when you take away from 10, you get 9. And from 9, it is 3. So that is the remainder. So what you notice here is that the correct answer is C. So square root of 0.1 is equal to 0.3, right? Do you notice one more thing here that was related to our question? Do you see 0.3 is actually greater than 0.1? Perfect. So we can also conclude that square root of a number can be a bigger number. Perfect. So what you notice here is that square root of a number can be greater than the number, right? So I just mixed this up. So that was the question 2, our very first question. So we have the answer of this question, which is, can square root of a number be greater than the number itself? The answer is yes. When the number is a decimal number, that is to say, if the number is less than 1, right? So if the number is less than 1, in that case, this is true, right? For example, 1 over 4, square root of 1 over 4 is what? Is half. And you know, half is greater than 1 over 4, right? So that's a very good example to give. Point 1 is also a good example in this case. So what you learned here is that we're trying to figure out what is the square root of a number without a calculator. Even if the number is very big, it can be found easily with our special division. You also notice that when we talk about square root, we are only considering numbers which are positive numbers. Clear? So square root, we are always considering numbers which are positive. Perfect? And if a positive number is greater than 1, then the square root is smaller. However, if it is less than 1, then the square root of the number is bigger than the number itself. So I hope you find it interesting and useful. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'll be great. Thanks for your time and all the best.